Hello. For our Accuweather analysis project, we gathered data for the city of Glasgow, Montana. Glasgow is located at 48 degrees north latitude and 106 west longitude. This is a map of Montana, and this is where Glasgow is located. It is about a 2-hour drive south of the Canadian border. Glasgow has a population of approximately 3,000 people. It overlooks the Milk River Valley at an elevation of approximately 2,000 feet, or about 600 meters above sea level. Glasgow is part of a semi-arid climate along with much of northeastern Montana. Their station identifier is KGGW. This topographic map of the U.S. shows Montana's location. Looking at this map, we can clearly see both sets of U.S. mountains, the Appalachians and the Rockies. Zooming in, we get a closer look at the elevations in the northwest. Glasgow is located here, on the leeward side of the Rocky Mountains, thus putting them in a rain shadow. As shown by this precipitation map, Glasgow typically receives approximately 13 inches of liquid equivalent precipitation annually. However, during the winters, they typically receive about 17 inches of snow. Due to its landlocked northern location, Glasgow's seasonal variance can be very extreme. For example, Glasgow has a record high of 113 degrees in July and a record low of negative 59 degrees in February. However, typical temperatures in Glasgow average in the mid-50s throughout the year. During the winters, temperatures average in the 20s, and during the late summer, they average around 80 degrees. This results in long cold winters and hot dry summers compared to much of the West. Glasgow rarely has thunderstorms. However, this picture of a supercell structure was captured by Sean Heavey in July of 2010.
Now we will begin to look at the data. First, we will take a look at the mean error from 15 days out and 45 days out. From 15 days out, for the most part, Accuweather had a cold bias up until about 10 days out, while Climatology had less of a cold bias, but for longer, approximately 12 days. Beyond that, Accuweather fluctuated between warm and cold bias until about 28 days out, in which they began having a very large cold bias, shown here. From then on, they slowly began getting closer to actual values, ending just slightly above the actual values. During this time, Climatology showed only a small warm bias. Continuing on, we will look at the average absolute error. In this aspect, Accuweather is actually more accurate than Climatology. Within 15 days, Accuweather had an average absolute error of about 5 degrees, whereas Climatology had an error of about 7.5 degrees. Sending the data out to 45 days, Climatology remained rather constant at an error close to 8 degrees. Accuweather, however, got steadily less accurate, peaking out at an error of 8.5 degrees from 32 days out, shown here. Beyond that, their error slowly began to drop.
To look at the trends in errors and forecast consistency, we calculated standard deviation. The average standard deviation was 5.35. The lowest standard deviation was on September 4th with a value of 1.41, and the greatest was on October 28th with a value of 9.34. We also use this data to look at the trends. We established that Accuweather did not handle the change in seasons well. In the last 2 weeks of September, the transition to fall, the standard deviation average was 4.95, whereas during the first 2 weeks of September, it was only 2.23. This happened similarly in the transition to meteorological winter. During the first 2 weeks of November, the average standard deviation was only 5.05, but then in the last 2 weeks of November, it jumped to an average value of 6.89. Also of note, there was a large spike in the standard deviation in mid-October.
In addition to looking at standard deviation, for our own curiosity, we looked at one day specifically to see how much it jumped around. We picked the last day, December 3rd, because it had most of its data points along with a forecast from 45 days out. What we found was actually very interesting. From 45 days out, Accuweather forecasted a high of 30 degrees. 4 days later, they lowered the high to 17 degrees. The forecast hovered there for several days until one day it jumped from 20 degrees to 40 degrees. It jumped back and forth like this for 2 weeks or so and then leveled off in the lower 20s. In the last 10 days of the forecast, however, the temperature jumped from the 20s to 16 back to 27. A few days later, it went from 14 degrees to 46 degrees to 9 degrees in 3 days, and the actual observed value was 18 degrees. While this day was likely an anomaly, it was still very interesting to look at the raw data. For our new error calculation, we used percent error. Percent error is calculated by taking the observed value minus the forecasted value, dividing by the forecast value and multiplying by 100%. Looking at the chart, you can interpret it this way. Values close to zero represent more accurate values, and higher values represent less accurate values. As shown here, forecasting from less than 3 days out was most accurate, and that was to be expected. Percent error continued an upward trend, meaning increased error as the days progressed, with the largest error being from about 33 days out, shown here. Surprisingly, after 35 days or so, the forecast started becoming more accurate, shown by the negative slope on the graph. The most accurate day beyond 35 days was 40 days out, which corresponded to about an 18% error, similar to approximately 19 days out. To distinguish whether or not Accuweather relied on climatology, we used a calculation we called correlation. We used a formula similar to the mean error and the absolute average error, but instead of using the observed value, we used climatology. Our results were very interesting. Looking at just mean error between climatology and Accuweather, we formulated this chart. Mostly what this shows is that between 26 and 40 days, Accuweather did not use climatology at all, which is represented by the large errors shown here. Looking at the mean absolute error, Accuweather had an average of a 5-degree difference from climatology. This corroborates the sentiment shown in the other graph that Accuweather did not utilize climatology much at all in the forecasting for Glasgow, Montana. However, it is of note that as the days progressed, the general trend of the graph does show a slight negative trend, evidenced by the line of best fit. This indicates that Accuweather possibly used climatology a slight bit as the forecast period grew longer. In our study of the Accuweather forecasts, there were several limitations to the study, one of which is the fact that we only studied high temperatures and not the lows or expected conditions. This can create an issue because oftentimes lows are more difficult to forecast because of the variance of heat during the day and the amount of cloud cover overnight. Also, the conditions for the day would have likely been very difficult to forecast for. From 40 days out, how can Accuweather say that there will be a little ice and then a little rain from a system that doesn't even exist yet? But yet they did that by shown in this forecast. In addition, sometimes they had snow predicted when the temperature was in the 50s, and this doesn't make logical sense. Analyzing these factors may have made the study more efficient. In addition, we only took data for 3 months. To make a better study, collecting data over an entire year or several years would make the evidence more conclusive and allow better predictions to be made. Also, this is a new forecast length, so their forecasters had to learn to forecast beyond the traditional 30-day forecast. We began collecting data less than a month after they aired this, so they likely hadn't perfected that skill yet. In conclusion, Accuweather's forecasts for the most part are not very good. The best they did was from about 3 days out, but that's to be expected. That's a traditional forecast. Beyond that, they had an error of about 5 degrees average or so, which is actually not a very good forecast. In addition, they had some logistical errors, such as having snow when the forecasted temperatures were well above freezing. However, with that being said, in Glasgow, Montana, Accuweather did a better job of forecasting than climatology, even 45 days out. To be honest, if you really need a forecast from 45 days out, you might as well just flip a coin. It may be more accurate. Otherwise, just wait it out for a more reliable forecast. Anyone have any questions?